You know, we're completely surrounded by computers. We use them for literally everything. But how many of us really know what's going on inside that box? Today, we're going to peek under the hood and get a real feel for how this incredible machine actually works.
Because, let's be honest, it's so much more than just a screen and a keyboard, right? And if you're a future programmer, or really just anyone who wants to be in control of their devices, you've got to understand its inner workings. Knowing its strengths and its limits, that's the key to unlocking what it can really do.
And that quote right there, that is our guiding principle for this explainer. We're not about to throw a ton of technical jargon at you to memorize. Nope, we're going to build a mental model together so you can just intuitively get how this machine, well, how it thinks.
All right, so let's dive in and start at the very, very beginning. What is the fundamental blueprint that every single computer, no matter how big or small, follows?
Okay, let's strip away all the fancy apps and shiny cases for just a second. At its absolute core, a computer is a surprisingly simple machine. It's built around one fundamental three-step process. And this loop right here, this is the DNA of every computer in existence. From a massive supercomputer to the phone in your pocket. It takes something in, it does something with it, and it gives you a result. Input, process, output. That's it. That's the magic. Now, to make all of that happen, every computer is really living in two different worlds at the same time. These two worlds are distinct, but they are completely interconnected. The best way to think about it is like a soul and a body. The software, that's the soul. It's the intangible world of ideas, instructions, and data. And the hardware, well, that's the body. The actual physical circuits and silicon that you can touch. The stuff that brings all those ideas to life. And even in that software world, there are layers. Think of the operating system, like Windows or Mac OS, as the master conductor. It manages everything and lets other programs run. Then, on top of that, you have the applications, all the tools you actually use, like your web browser or your favorite game. So that's the soul. Now, let's meet the body. Let's meet the physical team, the hardware components that are doing all the heavy lifting.
It's really a team of 5 specialists: input, output, memory, storage, and the big boss, the CPU. They all have to work together in perfect harmony to get anything done. Each one has a critical job to do.
It all starts and ends with communication. Input units are how we talk to the computer, with a keyboard, a mouse, or a camera. And the output units, that's how the computer talks back to us, by showing us things on a monitor, printing a page, or making sound through speakers.
But how does the computer actually think? I mean, what happens in that process step? Well, that brings us to the real heart of the machine, the two components that define its speed and power, the processor and the memory.
This is the central processing unit, or CPU. You've heard of it, of course. It's the brain. It's the engine that runs every single command. It's like a microscopic city made of billions, and I mean billions, of tiny electrical switches.
Seriously, billions of them. It's kind of hard to wrap your head around. Billions of microscopic transistors, all firing away on a chip smaller than a postage stamp, doing math at speeds we can't even imagine. It is truly mind-boggling stuff.
And this brain isn't just one big blob. It's got specialized departments. You've got the arithmetic logic unit. That's the mathematician, the one that crunches all the numbers. Then there's the control unit, which is like the traffic cop, directing where all the information needs to go. And finally, the registers, a tiny, super fast little scratch pad for whatever the CPU is working on right now.
Okay, so here's a question. If the CPU is this unbelievable speed demon, why do our computers sometimes feel, well, slow? The answer is a classic bottleneck. The CPU is lightning fast, but it spends a lot of its time just waiting around for data. Getting that data can be like asking a world-class sprinter to run a marathon just to pick up a piece of paper.
So to solve this problem, computers use a really clever system called the memory hierarchy. Think of it like your desk. The stuff you're working on this very second is right in front of you. The files for your current project might be in a drawer, and everything else, that's in a big filing cabinet down the hall. So here's how that plays out. All your files and apps live permanently on the slow but huge hard drive. That's the filing cabinet. When you open a program, it gets loaded into the much faster RAM. That's your main workspace. And the most critical bits of data are put in the ultra-fast cache and registers, right at the CPU's fingertips. It's a brilliant system for keeping that speedy CPU fed with data. But, and this is a huge but, there's a catch.
All of that super fast memory, the RAM, the cache, the registers, it's all volatile. That means if you cut the power, poof, everything in it is gone. Only the hard drive is non-volatile. It's like a fireproof safe that keeps your data secure even when the computer is off.
So we know the CPU is this brilliant general-purpose brain. But in our modern world, with all its amazing visuals, it needs a partner. It needs a specialist for the really demanding job of creating images and video.
And that's where the GPU, the graphics processing unit, comes in. If the CPU is a brilliant scientist who can solve any complex problem one at a time, the GPU is like an entire army of artists all working in parallel, all painting a small part of a masterpiece at the same time. That parallel power is what makes modern video games and high-def video even possible.
So there you have it. You get the pieces now, you see the elegant dance between the hardware and the software. So what's the next step? Well, it's learning the language to command this powerful orchestra. Learning to code is how you go from just being a user to being a creator. It's how you tell this incredible machine exactly what you want it to do. And that is where the real power is.